Welcome to the second Algebra 1 air test video that we have for you. In this video, we are specifically going to review the sample test questions for the Algebra 1 air test. And you do also have the answer document available to you that you can review on your own. But this is just kind of in case maybe some of the things on the answer document didn't make sense or were vague or you'd prefer an in-person walkthrough, then that's what this video is going to provide you today. Okay, so let's get started. This first question, very straightforward, which expression is equivalent to 8x to the third power, all of that to the 2/3 power. This goes back to your laws of exponents, but also the calculator, the TI-84, can help you complete this question. The part that you need to know from your law of exponents is when you have a lot of things inside the parentheses raised to another exponent. That exponent goes into everything. I don't know why that didn't go all the way through. It goes into everything. So it goes into 8 and it goes into a 3. So we have 8 to the 2/3 power, and we have x to the third power and also to the 2/3 power, and we just would need to multiply them. And I don't know about you, a number to a fraction, yeah, this is where our calculator really helps us out because we don't see any of that over here. So bring up your TI-84, and very simply, you're going to put 8, and this button right here, your caret button, this is your any exponent button. And you can see it gives you that little tiny number. It goes up to that. And we want to insert the fraction 2/3. So use your division sign. There's your 2/3. Now, if we were putting anything else up on here, it's prompting us to use the arrow button to get down off of that exponent. We didn't really need to do so, but I did so anyways just to show you. But we can go ahead and push enter, and it calculates it for us. The answer is 4. Now x to the 3 times 2/3, you could possibly do this yourself and get the number. If you're not very good at multiplying numbers and fractions, you could also do 3 times and put 2/3. Now I do like to put, just on the side of caution, fractions in parentheses just to make sure I'm crystal clear to the calculator. I want 3 times this fraction. So I tend to put parentheses in, I don't know, a little bit more frequently than I probably need to. But I'm just being careful. So I've put that in and it will tell us, oh, the answer is 2. So my exponent on that is 2. This is really not working out very well, is it? Okay. But we see here 4x to the second power is an option for us. That is A. And we can move on to the next question. So this question, Juan wants to rent a house. He gathers data on many similar houses, the distance from the center of the city X, and the monthly rent for each house Y are shown in the scatter plot. Juan models the data with a linear equation. Now the question says, based on the scatter plot, what could the number 1275 represent in his equation? So our options are the estimated rent for a house in the center of the city, the estimated minimum rent for the house far from the center of the city, the estimated change in rent for an additional mile from the center of the city, and the estimated change in distance from the center of the city for each dollar change rent. So before we actually decide which one of these, let's go over here and look at our graph. We see that rent is up the y-axis, and look at the numbers there, 200, 400, 600, 800. You know, we get to some pretty big numbers. And then distance from the center of the city in miles, that is like 2, 4, 6, 8, 10, 12. So right off the bat, we kind of get a hint just by looking at our scales. Because 1275, if we look at this, you know, it's going down. We could like sketch in a line if we want. It's kind of like, hey, it's kind of going down like this. If this line were to continue, it's not going to get out to 1275. So it's not going to be distance. We can automatically get that hint just from the graph. And so if we come here, I think there was one that said distance. Yeah, D, the estimated change in distance. It's not going to be distance because that number doesn't make sense for distance. We can tell that it's going to be related to rent. So let's go and look, where about is 1275? Let's kind of go see if we can find that. So 1275 will be between 1200 and 1400. This should be 1300. It's going to be somewhere close in there. Like, you don't have to get it exact, just about somewhere in there. Let me go ahead and get the line tool, and we'll just kind of put like a dotted line right there. Somewhere in there is 1275. So what does that make the most sense? Let's go back and reread our options. The estimated rent for a house in the center of the city. The estimated minimum rent for a house far from the center of the city, and the estimated change in rent for each additional mile from the center of the city. So clearly we probably should know what center of the city means because it's in all three of them. So let's look at that for a second. That does relate back to distance, distance from center of the city. So 0 would be you're not away from the center at all. You're at the center of the city. And then this would be your 1 mile from the center and 2 miles from the center. So the center of the city is right here. That actually is your y-axis. So A is the estimated rent for a house in the center of the city. That's not bad. It's not bad. Like that 1275 is close to just the line I sketched through. It's close to the dots here. So that's not a bad option, but let's just make sure there's not a better option here. So B is the estimated minimum rent for a house far from the center. So far from the center is kind of important because that's talking like out here, right? Far from the center, and 1275 rent is way up here. That doesn't match our data at all. So we can rule out B is not going to be it. So the other option we have is C, the estimated change in rent for each additional mile from the center of the city. Well, let's look at this. The rent is going down. We read it from left to right. The rent is going down. But this number is positive, and positive means going up. So that doesn't really make sense either, just because positive, up, negative would be down. So that doesn't really make sense either. So it's got to be A, which we said did seem reasonable. We just weren't sure that it was the best answer until we went and read through all of them. All right, our next question. A group of students measures the distance a toy car has traveled after different amounts of time. A table of the data is shown. The student wants to perform an analysis of the data set and consider removing the outlier point. In the answer document, which I know this is kind of a dated example question, select all of the quantities that will change if the outlier point is removed from the data set. So one really important piece that you need to know is outlier. What is that? Because this question really depends on you knowing what an outlier is. Now there's a lot of calculations that also needs to be taken in consideration, but what is outlier? Outlier is that point that kind of like sticks out beyond where most of the data is. Like it's kind of like a sore thumb. It really should stand out to you. So if we look at time in seconds, there's nothing that stands out. Like it just goes in order. If we go in distance, ones, twos, threes, fours, but we have that 11. That is our outlier because it's clearly not with the rest of the data. So you need to know that's the outlier point. And it says, select all the quantities that will change if the outlier point is removed. So that also means you need to know what are the before and after values, because you want to know the ones that will change. And we're talking about mean, which is where you add up all the numbers and then divide by how many numbers there are. We have the median, which is the physical middle, but you have to make sure the numbers are in order. And then the range, and the range is very simply the highest number minus the lowest number. So some of these you might be able to reason out without doing any of the math involved. For example, the range of the time. Time right here in seconds, the highest number is 15, the lowest number is 5. That does not change if that outlier is removed. If 10 is removed, we still have 15, we still have 5. So you can automatically rule out E as your answer because they want the ones that will change, and that does not. But if you look at the range of distance, your high number, if the outlier is involved, your high number is 11. And if you remove that, it's really going to change things. So you can automatically say, okay, yeah, you know what, F is going to change. And F is going to change by quite a lot because that 11 really made a difference. But you are more than welcome to go ahead and calculate this out if you'd really want to. With the outlier in there, high is 11.0 minus your low, which is 1.0. So 11 minus 1 is 10. But then if you take that outlier out, if you look at your data, your highest number then becomes 4.9 minus 1.0, and that is really different from the 10. So that's just another way you can say, okay, the range and distance, that's going to change. Now, the question said select all of the quantities. So we've got to check everything else as well. The cool thing is that your calculator will help you if you don't feel comfortable with doing all of these calculations. I know the median isn't too bad because you just got to put everything in order and you start crossing off. And you have to do it with time and you have to do it with distance. And then you have to take out your outlier and do it again with time and distance. So it can take a really long time to do it by hand. Now, one thing you can do is in the calculator. If you look here, you have a stat button as for statistics, and you also have a list button, and the list is in blue. So if you go to your list button, it says, okay, you've got different lists here. Let's just look at this. Let's go to L1. Let's push the stat button. I quit out of the list button. I went to stat. Let's go edit. Let's edit L1. And in L1, because this kind of looks like a table, that's exactly what we're going to do, is we're going to put, it started at 5, and then 6, and 7, and 8, and 9, 10, 11, 12, 13, 14, 15. And then if I use the arrow button, I can go back and put all of those distances in the table as well. So I'm basically recreating that table in the calculator. 3.4, 3.3. You do have to make sure you are going in order. You're not skipping any buttons, that you are entering the numbers correctly. Like there, I just accidentally clicked an extra button just in moving my mouse around. There's 11.0, and you can see it's across from the 10, so I know I'm on track so far. 4.2, 3.7, 4.8, 4.5, and then 4.9 should be my last one. It should be across from 15, and it is, so we're good. And let's go ahead and quit out of there. Let's go back to that stat button. Now if we go to calc, we have a lot of things in here. And if we just look at one variable stats, that's what we're going to look at. One variable as in we're just going to take a look at the time alone or the distance alone. We're not going to look at both of them at the same time. So that's exactly what we want. And we say, okay, L1, that is the list we want to go first. That is your time list. And we're just going to say enter for calculate. And then it spits out a whole bunch of numbers. And most of these we don't need. This first one is called X bar. That's another way of writing your mean. So it calculated your mean for you. And remember, this has the 11.0, your outlier in it, but your mean is 10. And if we scroll down, min, median, median, MED, your median's also 10. So it gives you your mean and your median, and they just so happen to both be 10. So I would write that down. The mean of time, oh, we don't need that big of a font. Okay, so with outlier, it's 10. And median of time with the outlier was also 10. And we can run the same thing for the distance. And so I'm going to go ahead and just start writing it down that this is what we're going to do. Because then we've got to delete our outlier and do it again. So this time we want distance. Well, this was L1, distance was L2. So we're going to go back. We're going to go back to our stat button. We're going to go to the calculate, one variable stats, but this time we want L2. So go second, list, that's where we get L2. There's also another way to do it. You can do it down here. But this is just one of the ways. There we go, L2, and we go, okay, let's calculate this. And this now calculates your mean on the distance. So let's just round it off, 4.06. 4.06, let's go down here for the median, 3.7. So 4.06 was the mean, the median was 3.7. All right, now we get to delete this values and just have the calculator do all the math for us again. So let's go to stat, edit, and then our outlier was, just passed it, 10 and 11. So we're just going to hit delete and come over here and delete, and we're good. Now we can quit, second quit, go back to stat, calculate, one variable stats. If you want to do them in the same order, L1 for time, L2 for distance, you're more than welcome to. I will go ahead and do L1, and that was just the second way to do it, second, and L1 was in blue. Here we have it. The mean was still 10. The median was still 10. So time didn't change. It was still 10 and 10. So those are not going to be the answers because we want the ones that will change. So let's do it again, but on list 2. So stat, calculate, one variable stats, but we want L2. So second L2, that's the other way of changing this. Enter, enter, calculate. Ooh, the mean changed, 3.37. What about the median? Median didn't, 3.7. So we've got another answer, 3.37. We have another answer, that is B. So the calculator really helped cut down the amount of time on this, of just adding all these up and dividing and adding all these up and dividing and doing it again, but without those values. We could just enter these in the calculator once and then have them run those tests for us. And we have both of our answers right there. All right, our next question. An analyst researches the relationship between different energy sources in each state for 2014. The data in the table shows the number of states that use coal and nuclear power as an energy source. Given that a state does not use nuclear power, what percentage of those states use coal? So all of our information that we need is up here in this table, and it tells us the state does not use nuclear power. So right here, nuclear, yes, no, not means this column. So we're looking at this column, and it says what percentage of those use coal. So over here for coal, we want yes, and it's just where those two overlap. So that means we want the 20 right there. But it doesn't just want 20 because it asks what percentage of those use coal. So we kind of need to know a little bit about percentage. Percentage is part over total, or you could think of it as whole. It kind of depends on what you're doing, what makes the most sense. And it's a fraction. And we have the number we want is 20. We have to think about that. Is that a partial number or is that everything? Well, it's clearly not everything because we have more numbers than just 20. We have 16, we have 2, we have 12. So this is a part number. So we know 16 is on top of our fraction. For the total, we just need to add up 16 plus 2 plus 20 plus, get my fingers working, 12. And figure out what that is. And we could do that with our calculator. 16 plus 2 plus 20 plus 12. Okay, that's 50. So we know our fraction is 16 over 50. But that's a fraction. That is not a percent. So even though percent is, part over whole, this is not our final answer. And most of you probably know how to get a percent from a decimal. So we need to get this 16 over 50 to a decimal. Let's do that using our calculator. 16 divided by 50. You know what? You got to tell me these things, you guys. Got to stop me somehow. Through the computer, you should have said, why are you using 16? I don't know. I clearly just marked 20 and then I didn't use 16. So, don't fall into that trap like Mrs. Collins just did. Please use 20. And I don't know what made me stop and double check that. I don't know. Maybe I was just thinking a calculator is only as good as the person is. And I thought I might want to double check that. It's worth doing, guys. Please do it. Because calculators will only do what you tell it to. And if you tell it to do something wrong, it's never going to tell anything differently. All right, there's our decimal, 0.4. And most of you probably know that to get from a decimal to a percent, you just take that decimal point and you swoop it over 2 times because percent means 100 and there are 2 zeros, and that's why you move it twice. So this becomes, you put in the empty swoop with a 0, it becomes 40%, and that's your answer, your final answer. Double check things one more time because, if you make one mistake, you might have others. 20 is our part. Our total was 50. You might double check. Did I type everything incorrect? Okay, that looks good. We made it into a fraction, into the decimal, 2 swoops over. Okay, we're good. It always pays to double check things, especially on these tests. All right, moving on. Ms. Don't know how to pronounce that. Musto? It doesn't really matter. In a new coffee shop, she recorded the number of customers she served between opening and noon for the first 20 days of business. Her results are shown on the graph. And the question is, which line best fits the data. Best being operative here. And we have four different line options. And we have our data over here. So for this particular question, you need to be in some particular knowledge. And that's because all of these lines are in the form y equals mx plus b, where m is your slope, which is rise over run, or you can think of it as y over x. And that simply means your number on top means whether you're going up or down, the number on bottom is left or right. B is much easier. B is your y-intercept, which is where that line crosses your y-axis. So when you're looking at these numbers, you always start with B. Always, always. And it says, okay, if you're just looking at these, we have 10, 20, 30, and another 20. So go to your y-axis. 10 is way down here, 30 is way up here, and 20 is kind of in between. You might be able to reason this out just by looking at it. Like your 3 dots, you know, there's one that's closer to 30, but the other one's like kind of spread down to 20. And you can probably reason, and it would be correctly so, that 20 should be your best fit because 10 is just too low and 30 is too high. You want your best fit line to be balanced as much as possible. So you can correctly cross out A and C just from your y-intercept. From the rest of this, you do need to have some knowledge of slope, and I would honestly just plan on graphing these lines very, very roughly. So your slope for B is just 2. It doesn't look like a fraction, rise over run or y over x. If that happens, you just need to make it look like a fraction. So 2 over 1. That's how you make it look like a fraction. And this one here, you don't see any numbers at all. And that's because you're expected to know if you don't see a number, the number is 1. And then you have to make it look like a fraction. So 1 over 1. And for slope, if they're both positive, think about that. Your y-axis numbers are positive when you're going up, and your x-axis numbers are positive when you're going to the right. And that's just following the numbers here. You know, if we wanted negative, it would be down or to the left. So this is saying go up 2 and to the right 1 from x marks the spot, from your 20. The difficult thing about going up 2 and over 1 is that our numbers are kind of tricky. So you may have to think about it, well, I've got 10 and 5, 10, 15, 20. So you may have to think of it as, okay, if I multiply this times 5, that's how I get to 10. So I'd multiply this by 5, so it means it goes over 5. You may have to do some extra reasoning to try and get this plotted okay. So up 10 over 5. See if I can get this dot marked there. Oh, and do pay attention to your numbers on the bottom because that was not over 5. This is over 5. So these questions can be very, very tricky. Let me change the line color to blue. And let's just sketch it in there. It doesn't have to be perfect. Just there's our sketch for B. That's blue. And then for D, we had 20, but it's up 1 over 1. And again, we don't really have an up 1 over 1 type thing. It's up 10 over whatever. So reasoning it out, if it's up 1 over 1, it becomes up 10 over 10. So our dot would be up 10 over 10. And again, you have to be very careful of those scales. All right. And again, for the best line, you want the one that balances between the dots. So our answer option is B here. That was the blue line. D was just too low. even though it had a good starting point, the slope was just too low. A linear model shows that the relationship between the number of grocery items purchased and the total cost of the grocery bill has a correlation coefficient of 0.97. Which statement about the variables is true? Now this particular question, before I even read any of the answers, it doesn't say what the lines are, doesn't give you any other numbers other than correlation coefficient of 0.97. You need to know what that means. So let's talk about that for a second. Your correlation coefficient, positive, and the ideal number is 1. And what that means is you have a strong relationship where both of your quantities are going up at the same time. If you have like a close to -1, it's also a strong relationship, but like usually it's an inverse where one thing is going up and the other thing is going down. But the closer you are to 1 or the closer you are to -1, it's a very strong relationship. And the further away your number is, so like 0.7 or 0.5 or even 0, I guess that's not a strong relationship. Or if it's 0, there may not be any relationship at all. And when you're reading through these statements, you are looking for the best answer. Even though it doesn't say which is the best answer, you're always looking for the best answer. So A here, purchasing more items causes a higher cost of the grocery bill. Well, yes, I think anybody could probably figure that out. If you buy more things, you have to pay more. So this is a really good answer. Is it the best answer? That remains to be seen. We're going to mark it. It's a strong contender. B, if a grocery bill has a higher cost, then more items must have been purchased. That's kind of the opposite of A. And again, it kind of makes sense. Like if you buy more groceries, you're going to have a higher cost. If you got a high cost grocery bill, you must have had a lot of groceries. Again, a very strong contender. Some people might be able to find the mistake in that logic, like if you're just buying really expensive items. But again, it does make sense. There is no relationship between the number of items purchased and the total cost of the grocery bill. That is C. Well, that's not what our correlation coefficient says. It is really close to 1. It says there is a very strong relationship, so it is not C. And D says very specifically, there is a strong relationship between the number of items purchased and the total cost of the grocery bill. So even though A and B were very good answers, they do make sense. It's specifically asking us about this correlation coefficient of 0.97, and that's exactly what the best answer is trying to get out of us, that we know that the number 0.97 is a strong relationship. So our best answer is, in fact, D. Henry places X marbles into an empty bucket. Each marble has the same weight. The weight in ounces of the bucket and marbles can be calculated using the expression shown, 3x plus 8. What does the term 8 represent in this expression? We have the weight of each marble, the weight of the empty bucket, the number of marbles in the bucket, or the total weight of the bucket and the marbles. So let's go back up here and figure out what's going on. Henry places X marbles into an empty bucket. Each marble has the same weight, and here's our expression, 3x plus 8. Let's kind of dissect that a little bit, even if you're not incredibly certain what's going on. We're told very specifically X is the number of marbles. So X is marbles right there. 3 being with X, that is related to marbles because they're tied together. They're joined at the hips through multiplication. And that just specifically refers to each marble has the same weight. So if you have 12 marbles, it takes into consideration you have 12 marbles. So 3, because it's with X, that is related to the marbles. So the only thing we don't really know about is that 8, which happens to be what it's asking us. So we have to think about, well, what are we weighing? We're weighing the marbles, and we know that is your marbles right there. So what's the only other thing you're weighing? Well, your marbles are going into the empty bucket. So that has to be your bucket. So which answer was the bucket? That was B. A shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost, f of x in dollars, of shipping x pounds is modeled by the function shown. And we have f of x equals 499x plus 575. What part of the function represents the fixed fee? This is very similar to the last question we just had. We do need to go back and reread the question. So shipping company charges a cost per pound plus a fixed fee. Okay, so very clearly plus is the plus sign. So one of these is the cost per pound, the other one is the fixed fee, so which one is which? Well, let's keep on reading. The total cost, f of x, so that's our total. We know it's not f of x, and in fact, we know it because it's not even an answer option. Of shipping x pounds. So this is telling us what x is, and we know 40.99 goes with x. Well, x is the pounds. That goes back to the cost per pound. So x very specifically is pounds. 4.99 goes with x because they are tied together. So it's not going to be 4.99. It's not going to be x. It's not going to be both of them because that is related to your pounds. The fixed fee must be 5.75. A function is shown. F of x equals 2/3 x plus 3. What is the value of f of 12? This just requires a little bit of knowledge about what this is saying. If you go back to your original function, you notice x is in the parentheses, but then the question asks you not about x, but about 12. That is saying very specifically, x equals 12, plug it in, the function, and calculate the answer. So instead of f of x equals 2/3 x plus 3, they want f of 12 equals, keep 2/3, but instead of x, you put in 12. And from there, you are more than welcome to go back to your handy calculator, 2/3, and you could do it like this, times 12 plus 3. You could also, just to be very safe, put it in parentheses. Either one is good. You push enter, and it will give you your answer for you. So f of 12 is 11. An equation is shown. Y equals 1/2 x plus 3/4. In the answer document, select all of the points that are contained in the graph of the equation. And we have all these points. So one thing you could do is you could use the calculator. It is in y equals format. So you could go up to y equals, clear this out, and you could put 1/2 x plus 3/4, and you might notice, oops, something didn't take. If that does ever happen, scroll over and there's INS is insert. It's in blue, so second insert. Oh, now what happened? Second insert 1. There we go, 1/2 x plus 3/4. You could graph it, and we want to know what all those points are on that line. You might say, let's take a look at the table, but the table does not, like, it has 0. 0 is 0.75. So right here, 0, 1/2, 0, 3/4. Oh, well, it's not 1/2 because 0.75 is 3/4. So you could have one of your answers just by looking at the table. But then 3/4 as your x value and 1/2 as your x value, it's not going to be on the table provided. So what you can do there is, if you go to the calculate menu, it very specifically says, okay, it can calculate the value for you. You just give it the x you want. So here is 3/4. So let's say calculate, if x is 3/4, what's y going to be? This is 1.125. Well, that's not 0, and it's not half, because half is 0.5. So we know none of those are good. So the last one you'd have to check is, what if x is 1/2? So you'd have to go back to the calculate, go back to value, x is half. And you can put in 0.5, you can put in half like that. 0.5, 1. There we see that is also an answer to this question. There are other ways of doing this as well. You could very simply go and substitute your values, because each point, every point is x first and then y. So you could go at this from the perspective of, instead of y equals half times x plus 3/4, you could go at it at the perspective of, okay, if you're doing a, y becomes half. And we have half times x. Well, x is 0 from that point. And you could calculate this out, and you could type that in the calculator, or, half times 0, that's 0. So half equals, it's saying 3/4. Well, no, it's not. Half does not equal 3/4. So you could also go the more traditional route of using substitution into your equation and doing your answer this way. Fred solved the equation 8 times the quantity 3x minus 7 equals -6 times the quantity x plus 7 plus 4 as shown. And you can read through the table if you'd like. The question is, Fred made an error between step 1 and step 2. And this is a two-part question. Explain the error that Fred made, and what is the solution to the original equation? So the first thing you need to do is find the mistake between step 1 and step 2. It tells you this is where it is. So you don't have to waste your time between what on earth they did from here to here. You just have to figure out what the mistake is. So let's take a look here. 24x minus 56 equals. There's nothing that they did over here on the left-hand side. So the mistake must be over here on the right-hand side. Well, -6x stays the same to -6x. So really what we need to figure out is, how did they go from these numbers here to 46? Like, how did that happen? If we can determine how it happened, hopefully that is our mistake. So actually, if we take a look at that, yeah, how did that happen? Because that 42 is negative. If we were to just type that in the calculator, -42 plus 4, well, we should have a -38 there, and we do not. We have a 46. So that actually is the mistake. Now, if you've actually figured out exactly how he got positive 46, kudos to you, because you can be even more specific in your answer. But even if you can't figure out how exactly they got positive 46, you could still have a very good answer that would get you points, saying the mistake was -42 plus 4 is not 46. It should have been, what was it, -38? whatever it was. That is still a very good answer that will get you points just by identifying that was the error. He combined those two numbers wrong, and it was not 46, it was 38. Now, if you also can figure out how they got 46, that is ideal and best. And how they got 46 was, you know what, 42 plus 4 is 46. So they just didn't take into consideration 42 had that minus sign, making it negative. That's exactly what Fred made a mistake on. But we can go ahead and go to part B. What is the solution to the original equation? So at this point, we've got to take step 2, which is 24x minus 56 equals negative 6x minus 38, and solve it from here, because everything else in the table would be wrong. Now, if you don't know how to solve this from scratch, you can use the table for hints. For example, on the step 3, they somehow got 30x all over here. So you could take a look at that and go, well, how would they do that? And kind of use that to help you if you are stuck. You do need to get your x's on the same side of the equal sign. And so I'm going to do a little bit of color coding for you. You get your x's on the same side and you get your numbers on the other side. So I'm just color coding in case you need some visual cues here. We are going to move the x's over first. And whenever you do that, you need to do the opposite. Whenever you're taking something across this equal sign, you need the opposite. So it's negative 6x. The opposite would be to make it positive, or you can think of it as adding. So we're going to do that on both sides because that's the golden rule of equations. What you do on one side, you do to the other. So your 6x's go away. They're gone because they make 0. 24 plus 6 is how we get 30. But don't forget your x, 30x. Now the minus 56, we didn't do anything to it, so it's still there. And then on the right-hand side, we still have the negative 38, but not for long, because again, we need to take those numbers and get them over to the other side. So this minus 56. Well, we cross the equal sign, we need the opposite to move it. So the opposite of minus or negative is to add it, or positive. It doesn't matter, it's the same thing. However you want to think of it. And then we have 30x equals whatever negative 38 plus 56 is. So negative 38 plus 56, 18. So we have 18. And notice when I'm solving my equations, I'm trying to keep my equal signs all aligned onto that line. That just helps with organization. All right, your last step is to get rid of the number in front of x, and that is almost always with division. You divide by whatever number that is. So we have divided by 30. That is super big on both sides. And so our answer is 18 divided by 30, which the best answer would be to check and see, will that simplify? So to your calculator, 18 divided by 30. And you might be able to get away with leaving it as a decimal. It is a kind of a nice decimal, so you might be able to say 0.6. But if you go to math, fraction, there's your simplified fraction, 3/5. And that's probably going to be the best answer, considering they left it as a fraction in the original. 3/5 is your answer. which expression is equivalent to 2x squared plus 3 times the quantity x plus 4? This is a FOIL question. FOIL is first, outer, inner, last, is to multiplying your polynomials and your exponents. So again, I don't know why that is not working very well when I use my mouse. Let's see if I write on something else, if that helps. So 2x squared times x. Well, the number here is 1. So 2 times 1 is 2. Yep, not really helping. So let's switch to typing it. 2 times 1 is 2. Is 2x to the third power. And then we have outer, which is 2x squared. Oops. I'm just fudging up my fingers today. All right, 2x squared times 4. And it's the plus 4 goes with it to say it's positive. 2 times 4 is 8. And the x squared. I really do want to switch back to writing. It's so much easier than typing this out. Inner is 3 times 1x, so it's the positive 3 times 1x. 3 times 1 is 3, and then don't forget your x. Then last is the 3 times the 4. So 3 and the plus sign goes with 3. 3 times 4. I just put the plus signs in just to remind me when things are positive or negative. Plus signs usually don't mess you up, but if it's negative, that usually does. So I like to put them in just to remind myself that I'm paying attention to what's positive and what's negative. Okay, so we're looking for the answer that has all of these parts. 2x to the third power, that rules out b. 8x squared, that rules out a. That rules out c. So it's got to be the last one. 3x is there, 12 is there. They're all positive, so they put plus signs in them, and there's our answer. Now, you might also prefer a different way. Instead of foiling, you may prefer using a rectangle and the array method, and that's perfectly fine, but I'm not going to use the time in the video to go over that right this moment. So if you have any questions, feel free to send a message to Mr. Phil Hart. All right, in the answer document, select all the expressions that are equivalent to 9x to the fourth power minus y to the second power. This is asking you about your knowledge of factoring and some of those special formulas that were on that formula sheet that are not provided to you, but you are expected to know. You can work this one a couple different ways. You've got all of the answers, so you could work the answers and see which ones go back to this 9x to the fourth minus y squared, or you can kind of reason your way from the question to the answers. Both will do just fine. So for example, answer A, 3x to the second power minus y all squared is saying 3x squared minus y, all of that times itself. That is what that question is saying. And you can FOIL that out. But if you FOIL that out, you're going to have more than just this, because if you go to your, oops, didn't mean the highlighter there. You guys are just getting all sorts of things in this video. 3x squared times y. Just your first and your outer. So 3x squared times 3x squared. 3 times 3 is 9. X squared times x squared is x to the fourth power. That's great. But 3x squared times negative y, you should have a term in there that has x and y both, because they're both negative. You're going to have negative 3x squared y as a term, and you're going to do it again when you do your inner. You're going to have it again. They're both negative. You're going to have another one. So that's not correct. If you go to answer B, this again, you need to know your 2 goes into everything. 3 to the second power, that is 3 times 3, which is 9. And then 2 times 2, because it comes into the 2 here. 2 times 2 is 4. So that gives us 9x to the 4th power. That checks out. Minus y, and that goes into your y. Y to the second power. So B checks out. C, 9x squared squared. Well, this 2 only goes into the parentheses. The 9 isn't in the parentheses. So that just makes it an x to the 4th power. That checks out 9x to the 4th minus y to the second power. So it's kind of like these were the same thing, except for they put the 9 on the outside, so you didn't have to worry about it. 9x squared squared minus y squared. Well, again, this 2 goes into everything. So 9 to the second power is 9 times 9, which is 81. You can stop there. It's not 81. And move on to E, 3x squared plus y, 3x squared minus y. So kind of similar to A. 3x squared times 3x squared, 3 times 3 is 9. X squared times x squared is x to the 4th power, because you're adding your exponents. 2 plus 2 is 4. So that works out. When you do your outer, oops, guess I'm just having fun with my arrows today. This becomes the same, negative 3 x squared y. And then when you do your inner, though, instead of having another negative 3x squared y, this one is positive 3x squared y. So the fact that one's negative and one's positive, but other than that, it's the same thing, that means they're going to cancel out and make 0, because negative 3 plus 3 is 0. Which means when you multiply y times y, you get y squared. And a positive times a negative is a negative. So this one actually does end up working out. So we had 3 answers to this one. Juan buys peaches and grapefruit at the store. He writes the equations shown to the model, the relationship between the number of pounds of peaches, P, and the number of pounds of grapefruit, G, that he buys. What is the total number of pounds of peaches and grapefruit that Juan buys? So it gives us some equations, and we're asked what is the total number of pounds of peaches and grapefruit. Now this is kind of important because typically when we're given 2 equations, we think, oh great, we have to solve it. So we would get our numbers, put them into our matrix, the inverse of A times B, and get the answer. But if we stop and think about this one, it just wants the total number of pounds. Well, the pounds of peaches is P, and the pounds of grapefruit is G. And we see one of those equations, P plus G is 2.5. Well, that's kind of our answer right there. It's kind of one of those tricky questions where it's really asking us, are you reading the question? Are you reading through everything that we're giving you? Saying the pounds of peaches and the pounds of grapefruit together is 2.5. So that is quite so your answer. And you would just write that in like a nice sentence. If in doubt, try and write a sentence. Unless literally the only thing it gives you is maybe like that part where you just enter in numbers, like it might give you that. In that case, you really just, you can type in 2.5. But if they give you a place to write it out, you can write, they give you the equation P plus G is 2.5. P is the pounds of peaches, G is the grapefruit, so together they're 2.5 pounds. All right, question 24. A theater sells tickets for a concert. Tickets for lower level seats sell for $35 each, and tickets for upper level seats sell for $25 each. The theater sells 350 tickets for $10,250. How many tickets of each type were sold? This is a very classic, you've got to solve your equations that you set up. Now, it gives you two sets of information. One is about money, because it says the lower level seats is 35 each and the upper level seats are 25 each. And it tells you how much money together, 10,250. So one of your equations that you're going to set up, and I'm going to use L for lower and U for upper, is that we know 10,250. So 35 lower, 25 upper, money-wise, we get $10,250. Your other equation is much harder to set up because you have to think about it. Usually it's just about raw quantities, lower and upper seats. You have L amount of lower seats and U amount of upper seats. The first equation was cost, money. This was just how many. Go back to your equations, it tells you there are 350 tickets. So now you have your equations, and you do need to remember those are ones in front when you set up your matrices. And you're going to put $35, $25, 1, and 1 in matrix A. And in matrix B, you're going to put in 10,250 and then 350. And then you're going to use A inverse 1, B. You're just going to type that all in the calculator and it'll spit out the answer. I've taken the liberty to go ahead and fast forward through that. If you need to know how I did that, go back and rewatch the previous video where I explained how to do matrices and put it in the calculator. But there we have A inverse 1B, and it's in alphabetical order because my L's were first and my U's were second. So 150 lower seat tickets and 25 upper seat tickets is my answer. Population of rabbits on a large island doubles every year. On January 1st, the population is 150 rabbits. Which equation can be used to find the number of years X it will take for the population to reach 4,800? All right, you might recognize just from your math class what type of equation this will yield. If you don't recognize it, if you look at your answer options and you see the answer is 4,800 and then you've got exponents involved, that should be your next clue that exponents will be involved. But if you have no idea what to do, I would just recommend trying to make a very simple table and seeing if you can reason it out, because that is really a good strategy for this question. So we have years. We'll start with that because years is X. And we know the first year, on January 1st, the population, which will be our answer. Population is just 150. That's what we start off. Actually, that's probably not even year one because it doubles every year. So we really want, that's not even after the first year. After the first year, we know the population doubles. So that's 150 times 2, which gives us 300. And in the second year is 300 times 2, right? Because the population doubles. Well, other than like times 2 and getting the answer that way, and we could keep on going. Year 3, it would be 600 times 2, which would be 1,200. We could actually get the answer this way and just keep on going. But we're looking at this to try and figure out what the equation should be. And nothing really pops out because everything has 150 and only our first one has 150. So we kind of have to think about other ways this was. Remember, we're just taking 150 times 2. That was our 300 times 2 again. So, let's see, we're going to clone this. So for this line here, we could rewrite it as 150 times 2 times 2, because that was 300. 300 was this 150 times 2. And we could do the same thing down here. This is now 600. 150 times 2 is 300, times 2 is 600. If you clone it again, down here for 600 times 2, well, that's all 600. Just put in your other times 2, and you get 1200. This is kind of weird, but this is what we need to see the equation. You see how every year we're just doing another times 2? Well, that's saying, and furthermore, it's matching your number of years. There's 1 times 2 here. There are 2 times 2 in year 2. There are 3 times 2s here. Your exponent is on your 2, because 150 is staying the same every time. There's no addition involved, never was. It's all about multiplication. So even if you don't get this part, you can clearly see there's no addition involved just by this alone. So you could rule it out to B or D and just get a really good guess. But the answer is D, because you're just putting more times 2s, times 2s, times 2. It's always times 2 that you're putting an extra one on, and so that is where your exponent goes. All right, for the last few questions, a lot of them are on your quadratics. And most of these, other than this last question here, most of these are really just putting it into your calculator and using the functions on your calculator. So let's go through them, but I'm going to kind of shorten the process a little bit. A grasshopper jumps off a tree stump. The height in feet of the grasshopper above the ground after 2 seconds is modeled by the function. So here's our function. After how many seconds will the grasshopper land on the ground? Okay, so we're going to come to our calculator. We're going to go y equals, clear out whatever we had in there before. And then we need to put this in. So negative, and instead of t, we just have x to the second power, plus 4/3, use your division for your fraction, 4/3 x, plus 1/4. And then we're going to hit graph. All right, and that's what I mean by quadratic. It is a U-shaped. So let's think about this a little bit. The grasshopper jumps off the ground and then he lands on the ground. So this actually kind of looks like what a grasshopper might do, jumps up and jumps down. But some of it doesn't really make sense because these are negative numbers. You don't really have any negative numbers when you're dealing with distance and time. So this, if you can just, I'm going to zoom in just a little bit. Just to imagine things a little bit. Like if you can just imagine this is where he's taking off from the ground, and this is where he's going to land on the ground. So your x-axis is kind of like your ground. He's going to jump and then land. And the reason why this may not exactly be on 0 here is because, you know, it's a grasshopper. You're not going to perfectly model this situation with numbers. But that's kind of what we try to do in math. So he's jumping and then he lands. So this is where we go back to the calculation menu. We need to know what this is. So second, calculate. It is a 0. 0 is another word for an intersect, like x-intercept, y-intercept. That is your 0. Not intersect, because intersect is usually 2 lines. You just want a 0. And so you're going to make sure this is on the left side. It normally, unless you play with the trace, it almost always is. It's on the left side of over there. It's quite a ways on the left side, and that's okay. On the right side, so scroll over. There we go. It's to the right. It always has that guess. We don't really care. There we go. 1.5 seconds has elapsed and the grasshopper's on the ground. And so your answer is going to be 1.5 seconds. The equation of a function y of t is shown. Y of t equals negative t squared plus 14t minus 40. In the answer document, select all of the statements that are true about the graph of y of t for 6 is less than or equal to t, which is less than or equal to 8. This is another one where we come to our graphing calculator, we go back to y equals, clear whatever out, and we enter it in. Plus 14t, which becomes 14x, minus 40. Now, if you notice, because I messed with the zoom, we're not going to see anything. So if we go back to zoom, 6 is how you reset it, standard. See if we see anything, and we do. So it's off to the side, but we're good. But then we need to go back to our question, because really it's just asking us to worry about, and again, x is t. So where is x between 6 and 8? So 1, 2, 3, 4, 5, 6, and then 7, 8. It is just a little bit. So let me see if I can isolate this for us a little bit easily. 1, 2, 3, 4, 5, 6, 7, 8. All right, we want the graph. There we go. That's all that it's asking us to consider at this time. So all of the statements that are true. Okay. So, oh, that's not what I wanted. I wanted this. Okay. The value of y of t increases over the interval 6 to 7. Well, remember, 7's in the middle. So 6 to 7, it goes up. Up is increase. That is correct. A is correct. And then B says the value increases over the interval 7 to 8. Well, 7, which is the middle, to 8, that's going down. That is not increasing, so B is not one of our answers. C says the average rate of change over the interval is 0. Well, rate of change is another word for slope. So if you see here, the slope is going up and then it goes down, but it goes up and down equally. It's perfectly symmetrical. And when that happens, even though it goes up and then it goes down, yes, it's going to average to 0, because remember, averages, you add them all up and divide them. And because it's perfectly symmetrical, when you add them up, you're going to get 0. So C is also a true statement. D says the value is constant over the interval. Well, no. Constant means it's the same. And we've just talked about it goes up and it goes down. It's not constant. And the last one is the average rate of change over the interval 6 to 7 is the same as the average rate of change over the interval 7 to 8. Well, we talked about this a little bit. It is symmetrical. So they're kind of the same, right? But this goes up, this goes down. What do we know about numbers that go up? They are positive. And what do we know about numbers that go down? They are negative, or at least as far as slope is concerned. That is very much a true statement for slope. Positive is up, negative is down. So are they the same? No, they're not actually the same. Even though they're symmetrical, they're not going to be the same, because one is positive and one is negative. The numbers, like it might be positive 5 and negative 5, the numbers will be the same, but you cannot say that they are the same in the answer because one's positive and one's negative. So our answers are A and C. A function is shown. What is the minimum value of the function? You've got some options here. You might recall off of that extra formula sheet, this is a very specific form of a quadratic equation, and you can pick out the minimum value just by knowing it. You don't have to do any math as long as you know that piece of information. You can go very specifically to the minimum value is whatever's opposite of the parentheses with x. -2 becomes +2. And then the number outside is 3. So you can go very, very quickly to the minimum. If you do not remember that though, we can once again go to our handy dandy calculator, push this in, x minus 2 squared minus, plus 3. And again, lesson in double checking. Make sure you are double checking that what you're putting in matches what you are given, because calculators are only as good as their users. Graph it. It does actually pop up. And the minimum here, we're going to go to our calculations screen. And one of those options was minimum. And it works very much like 0. It's going to ask, where is the left of this minimum, which I don't even see my cursor, but it says it's at x is 0, so it's got to be way up there somewhere. That's to the left. I'm happy with that. And it puts a little marker to double check. You just may have to start over again if you don't do it. All right, I am to the right. It has that guess value, and ta-da, 2, 3. It gives you the minimum right there for you. So there we have our answer for our last example on quadratics. All right, our final example question, the graphs of two functions, f of x and g of x, where g of x equals f of x plus h are shown. Now that actually just kind of sounds scary right from the get-go, but we have a graph that says based off that graph, what is the value of h? It's really not that bad of a question if you can kind of calm yourself down to think about it. Here's f of x. And here's g of x. It says g of x equals f of x plus this mystery number h. Well, just go to 0. 0 is the easiest place to look at this because we see f of x is 0 at 0. So we know this is 0 at 0. But where's g of h? G of h is at 5. Sorry, g of x. G of x is at 5. We know it's 5. Well, plus h has to get us to 5. So h has to be 5 because 0 plus 5 is how we get to 5. So it's really not that bad if you can stop and think, how can you use the graph that they're giving you? How can you use what you know about graphs and reading information to get this h value? And this is one of those examples where you would just very simply, you could push in the number 5 and you're done, or you could type in the number 5 and then you're done. That is not a calculator, it's just to put your answer in the box. So there we are, we're done with your walkthrough of the example questions for the air test for the Algebra 1 test. If you do have any questions, please email your teacher or maybe another teacher that you're comfortable with, and we will help you get straightened through this. But use these tools to help you prepare for your air test. Good luck.